In this video, we're going to solve applications involving parabolas from 9.2. Let's go ahead and look at the first problem. The cables of a suspension bridge are in the shape of a parabola as shown in the figure. The towers supporting the cables are 500 feet apart and are 100 feet high. If the cables touch the road surface midway between the towers, what is the height of the cable at a point 125 feet away from the center of the bridge? So since this is a parabola that opens up, we know it's in the form of x squared is equal to 4ay, and we're going to put our vertex at 0, 0, so that we can have a form like this without an h or a k. Visible in the problem, we get to choose our coordinate system, and we try and keep the vertex at 0, 0 as much as possible. That puts this point over here at 250 and 100. We'll just use the positive one. There's also a point over here at negative 250, 100. You can use that point if you want as well, but those are our two known points. We're going to have another point that's here at 125 something that we're trying to solve for. So let's go ahead and solve for A by sticking in 250 here and sticking in 100 here. So 250 squared is the same thing as 25 squared times 10 squared. 25 squared is 625. 10 squared is 100. And this is 4a times 100, so the 100s will cancel. And a is going to be 625 over 4. So when I stick that back into the original equation, x squared is going to be the 4 divided by the 4. They'll cancel each other out, and I'll be left with 625y. Now when I stick in my 125 for my x, then 125 is 25 times 5. So this is 25 squared is 625 times 5 squared is 25. 625 times y, and the 625s will cancel, and y is 25. The reflector of a searchlight in the shape of a paraboloid, that's a three-dimensional parabola shape of revolution, has a diameter of 32 centimeters. So that means that if I go halfway across here, that it's going to be 16 something. It also has a depth of 32 centimeters. So that point there, I'm going to call 1632. I'm going to call this point negative 1632. That lets me call this vertex down here 0, 0. We want to find out where the light source should be placed, which is going to be at the focus. So we want to find out how far along that axis of symmetry the light source should be. That's going to be our A value. So this is going to be x squared equals 4ay. 16 squared equals 4a times 32. So 16 times 16 over 32 times 4 equals a. 2, 1, 4, 1, 2, a equals 2. If I had simplified all that down, I think it comes out to be 256 equals to 128a. And I could have divided here, and a equals 2. All right, and we have a searchlight again that's in a paraboloid shape. We have the light source given to us as 1 foot away, so a equals 1. And the opening is 6 feet across, so that means that this point here is going to be 3 something. And we know that this point down here for the vertex is 0, 0. So we're in the form of x squared equals 4ay. X is going to be 3, a is going to be 1, and we're going to solve for y. 9 equals 4y. 9 over 4 equals y. And this is going to be 2 1/4, or 2.25 is y. And that's our answer. We'll come back next time and we'll start talking about 9.3. See you for the next video.